Good morning, dear students. Today we are going to see our next point, that is trigonometric identities. Okay, so this is the last point from the chapter. So there are some three identities we are going to learn, and we are going to use those identities to solve different type of examples or to give the proofs of different examples. Okay, so see here what is trigonometric identities? What is mean by identities? Okay, identities we have seen in algebraic identities we have seen, that is a plus b bracket square, like that 10 11 identities we have seen already. Understood? This what is the definition of identities? We can see here an equation involving trigonometric ratios of an angle theta. Okay, here we have taken angle theta is said to be a trigonometric identity if it is satisfied for all values of theta for which the given trigonometric ratios are defined. Okay, means that result is constant every time. Okay, means that result we can use to solve different type of examples. Okay, so that is known as identity. Okay, so already I told you before this we have seen, that is first one identity we are going to see, that is sine square theta plus cos square theta is equal to 1. Okay, so this identity we are going to prove now. Understood? So we need to think about theta. Okay, so maybe theta is 0. Okay, maybe theta is 90 degree. Okay, or maybe theta is between 0 and 90, that is acute angle. Okay, so we need to think about three conditions. Getting everyone? So first we will think case 1 is first, that is theta is equal to 0. Okay, theta is equal to 0. So how we can write this equation? LHS we are going to use and we will solve. Okay, so sine square is 0 plus cos square is 0. Okay, so what is sine 0? What is the value of sine 0? Sine 0 is 0 and cos 0 is 1. Okay, so 0 square, here it will come 0 square plus 1 square, so it will be 1 square is 1. So sine square 0 plus cos square 0 is equal to 1. Understood? So when theta is 0, that time result is getting 1. Okay, so this was the first case. Now we will see case number 2, case second. Okay, what is that? When theta is equal to 90 degree, theta is right angle. Understood? That time what is the result getting, same or different, that we need to check. Okay, so here sine square 90 plus cos square 90. Okay, so what is sine 90? Sine 90 is 1 and cos 90 is 0. Okay, so again definitely we will get 1, so 1 square plus 0 square, so 1 square is 1. So again in second case also we got the same result. Okay, now we will think about the third case. What is that third case? When case number 3, that is when theta is an acute angle. Okay, means less than 90 degree and greater than 0 degree. Means maybe that is 30 degree, 45 degree, 60 degree, any. So we have taken the word acute angle. Okay, so because 30, 40, 60 all are acute angles. Understood? So now for this we need to think about the figure. Okay, so suppose we will take a figure. This is angle theta, which is acute angle. Theta is acute angle. Understood? So this is x-axis, this is y. Okay, so this is A, this is M, this is P. P is 90 degree. Understood? Now, when acute angle, if you will use here Pythagoras property, then what we will get here? AP square plus PM square is equal to AM square. AP square is equal to AP square plus PM square is equal to AM square. AP square plus PM square is equal to AM square. Understood? Now, if AM square, okay, so this is according to the Pythagoras property we have seen. Pythagoras theorem. Okay, now what we can do here? See, if I am thinking, what is our result? We need to prove sin theta and cos theta. So, what is sin theta? sin theta is equal to opposite side upon hypotenuse. So what is opposite? MP upon hypotenuse is AM. Sin theta is equal to MP upon AM. Okay, and what is cos theta? Cos theta is equal to adjacent upon hypotenuse, that is AP upon AM. AP upon AM. Okay, so now finally we will use here sin square theta. LHS we will take sin square theta plus cos square theta. What will come here? What is sin theta? MP upon AM. MP upon AM square plus cos theta. Cos theta is AP upon AM. AP upon AM brackets. Okay, so we will solve further, then we will get MP square plus here we will get AP square. Here denominator is same, so we can use the same denominator, AM square. Okay, MP square plus AP square upon AM square, because denominator is same. But here MP square plus AP square is equal to what is coming? MP square plus AP square is equal to AM square. So this we can write AM square. Okay, so AM square upon AM square. AM square upon AM square. AM square upon AM square is what? 1. Understood? So sin square theta plus cos square theta is equal to 1. Okay, so we got the same result for in all the three cases. Sin square theta plus cos square theta is equal to 1. Okay, so this identity we need to use to solve different type of examples. Now this result we can use directly. Okay, because this is we have given here. Understood? In all the three cases the result is same. Okay, so the same we can write sin square theta is equal to 1 minus cos square theta. Sin square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sin square theta. Okay, so these results we can use the same identity, we can use it different. Got it everyone? So this was the first identity. Okay, see, our second identity is sec square theta is equal to 1 plus tan square theta. Sec square theta is equal to 1 plus tan square theta. Okay, so figure I have taken here, that is in triangle PMA, angle M is right angle. Okay, so in triangle APM, angle M is equal to 90 degree. Angle M is 90 degree. Angle A is equal to theta. Okay, angle A is theta. So now here we will use by Pythagoras theorem. We can say here AM square plus PM square is equal to AP square. Okay, AM square plus PM square is equal to AP square. Understood? Now what we are going to do? We are going to divide both the sides by AM square. Okay, so AM square plus PM square upon AM square is equal to AP square upon AM square. Okay, now we will make denominator separate, that is AM square upon this AM square is equal to plus PM square upon AM square. PM square upon AM square. Okay, is equal to AP square upon AM square. Okay, so now here this is AM square divided by AM square, so definitely that is going to come 1 plus PM square upon AM square, or that is PM upon AM, that is angle theta is here, PM upon AM is opposite side divided by adjacent side, means what? Tan theta. So we can write here square is given, so we can write this tan square theta. Okay, tan square theta, or if you want you can write here PM upon AM bracket square. PM upon AM bracket square, so PM upon AM is tan theta. Okay, so that also step we can add here, that is this is 1 plus PM upon AM bracket square is equal to AP upon AM bracket square. Okay, so further we will solve that. This is that we will get here 1 plus PM upon AM. Just now I told you PM upon AM is tan theta, so tan square theta. Okay, tan square theta plus AP upon AM plus AP upon AM. Okay, hypotenuse upon adjacent side is what? Sec theta. Okay, that is sec square theta. So sec square theta. Okay, so this is our identity. Sec square theta is equal to 1 plus tan square theta. Got it, everyone? So now from this we can use different results. See, tan square theta, how we can write this? Sec square theta minus tan square theta is equal to 1. Sec square theta minus tan square theta is equal to 1. Sec square theta minus tan square theta is equal to 1. Okay, or we can use sec square theta minus tan square theta. So this result we can write sec theta minus tan theta, another bracket, sec theta plus tan theta is equal to 1. Okay, a square minus b square, a square minus b square we can write a plus b, a minus b. Okay, is equal to 1. So if you want sec theta minus tan theta, then you can write 1 upon sec theta plus tan theta. We can change in RHS, sec theta plus tan theta. Understood? So this is the main identity. From this we can use different forms. Okay, according to the need. So first one we have seen sin square theta plus cos square theta is equal to 1. Now 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta is equal to sec square theta. This is the second identity. Okay. Okay, see, third identity is cosec square theta is equal to 1 plus cot square theta. Again we are going to use the same figure. Okay, so here in triangle APM, angle M is equal to 90 degree, angle M is 90 degree, angle A is equal to theta. Okay, so by Pythagoras property, AP square is equal to AM square plus PM square. AP square is equal to AM square plus PM square. Understood? Now what we are going to do? Before this we have divided by AM to both the sides. Now we are going to divide by PM in LHS and RHS. Okay? So AP square upon PM square is equal to AM square plus PM square divided by PM square. Okay, now we are going to make denominator separate. So you will get here AP square upon PM square, AP square upon PM square is equal to AM square upon PM square plus PM square upon PM square. Okay, so both can be cancelled and there will be 1. Okay, so now taking AP upon PM, AP upon PM. So AP upon PM bracket square is equal to AM upon PM, AM upon PM bracket square plus PM square upon PM square will be 1. Okay, now AP upon PM, this all we need to write in terms of angle theta. Okay, so AP is the hypotenuse upon PM, PM is the opposite side. Hypotenuse upon opposite side means what? This is cosec. Okay, so first thing we got cosec square theta. So this I can write cosec square theta is equal to AM upon PM, AM upon PM. Okay, opposite of tan, that is cot. Okay, so cot square theta plus this one. Okay, so we got the identity cosec square theta is equal to 1 plus cot square theta. Okay, so this is the third identity which we are going to use. Understood? So now again the same thing, cot square theta, how we can write cot square theta is equal to cosec square theta minus 1. Okay, so this can be written as cosec theta plus 1, cosec theta minus 1. Okay, so that answer we can shift here. Okay, but main identity is this we need to use according to the need. Means whenever we need cot square theta, that time we can use cosec square theta minus 1. Okay, sometimes we need to replace 1 is equal to cosec square theta minus cot square theta. Okay, but identities we have learned 3 identities today. So we are going to use the identities to solve different type of examples or different type of proofs. Okay. So today you all have to watch carefully all the three identities, video of these three identities, and you have to write down in the notebook. Okay. Thank you very much.